We are going through lesson 5.5's homework in the textbook, and we are starting with number 1. So it says grass snakes and rattlesnakes are found in the Great Plains. Grass snakes grow up to 20 inches, rattlesnakes to 45. We're going to express the ratio of rattlesnake length to grass snake, so that's important. Rattlesnake to grass snake. So we got to go in that order. So if we have rattlesnakes is 45, that has to go first, comparing it to the grass, which is 20. So if we're going to set it as a fraction, then that means for part A here, we have to go in the order that it gave it to us. So rattlesnake to grass snake, 45 over 20. And you're going to go ahead and simplify that. You can do it in the calculator or just divide those by 5. And fully simplified, that's 9 over 4. And if you're going to express that as a percent, you're going to go ahead and divide 9 divided by 4, 2.25. Now that's not the percent. You always have to move it 2 spots. This should make sense. Normally when we talk about percents, it's a smaller number compared to a total. So it's going to give us a small percentage, but this is a big number compared to a small one, meaning it's over 100%. 4 out of 4 is 100%. So 9 out of 4 is well over 100%. So when you look at this number and you move it 2 spots, it should make sense. It's 225%. So 9 divided by 4 equals 2.25, which equals 225%. Number 2, an item is on sale for $16. It originally cost $28. What's the discount rate? So we're going to compare the amount that we saved, because that's the discount, to the original cost. So it was $28. And we're not going to compare the 16 to that, although you could and then go further and figure out the discount rate. But it's easier if you just figure out what was the discount, how much came off the price. So if it went from 28 to 16, they took $12 off the price. So we want to know, since 12 came out of 28, what percent was that came out? So we're going to go ahead and divide. It's going to look like this. You move it 2 spots. You would round it up, I would say, with the 8 making this a 43%. Now we did round, so you can use the squiggle, or you can say about 43% for part A. Part B now, if the tax on the sale price is $1.04, what is the tax rate? So the sale price is 16. So the percentage is not based on the 28, it's based on the 16. So we're going to put the 16 on the bottom, and we're going to compare the $1.04 to the 16. So when we compare that, that's going to give us the percent that this is of 16. So 1.04 divided by 16. And again, you move it 2 spots. So it's going to go over, and it's 6.5%. Moving on to number 3. All right, so the recipe for fruit juice calls for 1 part fruit punch, 2 parts ginger ale. So that's a total of 3 parts, but the way we're going to represent that is 1 part, which I'm just going to call P, and 2 parts, so 2P. Now together that is going to be 3P. We'll simplify and put those together. A person wants to make 5 gallons, so normally you would say equals 5, but it says how many quarts of each ingredient are needed. So instead of using the 5 gallons, let's just use the number they gave us. 5 gallons is equal to 20 quarts. So we're taking 20 quarts, we're basically splitting it into 3 parts. 1 of those parts is the fruit punch, 2 of those parts is the ginger ale. So you're splitting it in 3, and that you can see algebraically here when we combine 1 part and 2 parts is 3 parts. We're going to actually take the 20, we're going to split it into 3 pieces. And so this is what 1 part is worth, 20 over 3. But if we want to simplify that, in this case, a mixed number makes sense, because in real life you wouldn't say 20 over 3. 3 goes into 26 times. We're at 18. That means there's 2 left over. So each part is 6 2/3. And if you take that 3 times, 6 2/3, 6 2/3, 6 2/3, you end up at 20. So one of those parts is 6 2/3. So this is going to ask you how many quarts of each one. So the one that's 1 part is the fruit punch. So the fruit punch equals P, which equals 6 2/3. And if you said 20 over 3, that's fine. And your ginger ale equals 2P. So it's going to be 2 times 6 2/3. And that comes out to 13 1/3. And you can do all that multiplication in your calculator. But the two parts, the two different pieces are 6 2/3 and 13 1/3. And again, if you added those together, 16 and 13 is 19 plus 2/3 and 1/3. That's an extra 1. When you put those together, that gets you back to the 20. So we're splitting the 20 into 3 pieces and then dividing it up. One of those parts, fruit punch, 2 parts, ginger ale. Number 4, very similar. Paint mixture calls for 7 parts of this oil. So that's 7P. And if you want to use an X instead of a P, it doesn't matter. 5 parts solvent, so 5 parts. Plus 1 part pigment, so that's just a 1P or a P. How much of each ingredient is needed to make 60 gallons? So this is all going to equal 60. So we're going to take that 60 and split it into all of these different pieces. So we got to put them together. So if we do 7 plus 5, that's 12. Plus 1 is 13P. So we're splitting this up into 13 pieces. The 60 gallons gets cut into 13 pieces and then spread 7 to this, 5 to this, 1 to this. So we're going to divide by 13. And 60 divided by 13. Not a great number. So this is one you may want to just put it in as a fraction. But if you try that, I don't think it's going to simplify at all for you because 13 is prime. So when you do that, you get that. So this is one you may want to actually turn into a mixed number as well. So going back to that scale, how many times does 13 go into 60? So we're going to actually divide 60 divided by 13. Goes in 4 times. So it's going to be 4 and then something's left over. If we do 4 times 13, we're at 52. So if we're going to 60, that means there's 8 left over. So each part is 4 and 8 over 13. Now when you go to plug it in your calculator and multiply all the parts, it's probably easier to just keep it as 60 over 13 in terms of doing the math in the calculator. It's easier to plug this number in than this, although both will work. But when you give your final answer, this makes more sense. This is more real world, where 60 over 13 is a little more algebraic. But they're equivalent, so both would be fine. So question's asking for how much of each ingredient. So we're going to have our 7P, our 5P, and our P. So we already know the P is 4 and 8 over 13. And then these, we're going to do 7 times that and 5 times that. So 7 times, I'm going to go ahead and use, again, the equivalent fractions. So 60 over 13. Multiply, get 420 over 13. And we'll go back and turn that into a nice number. Let's also, while we're here, do the 5 times the 60 over 13. So 300 over 13. So those are the correct answers, but we do want to make them a nice usable number. So we want to know how many times is the 13 going to go into 420. So divide. It's going to go in 32 times. Something left over, that's what the decimal tells us. So if we took 32 13 times, we're at 416, so that means there is 4 left over. So 4/13. And then 300 divided by 13. 13 is going to go in 23 times. Something's left over. So if we take 23 13 times, we're at 299, which means 1 is left over. Okay, number 5. So a team has won 11 out of 18 games. If the team wins its next 2 games, what's its winning percentage? So winning percentage, you divide the wins by the total. So right now, if you wanted to find the percentage, you would do 11 divided by 17. But for part A, they're saying we've won our next 2 games. So we've gone from 11 wins to 13 wins. And our total games has gone from 17 to 19. So our winning percentage is going to come from dividing that. And it says round your answer to 3 decimal places. So we're not going to give it as a percent. We're going to leave it as a percentage, which is the decimal. So 13 divided by 19. And it says round to 3 decimal places. So it's 0.684. The 2 means keep it the same. So we are leaving this 0.684. Okay, part B. If the team loses its next n games, what will its winning percentage be? So think about what we did, and they're going back to the original is what they're looking at. If this is how many games you've won, and they're talking about losing all the rest of your games, that number is not going to change. So when we express this, the 11 is going to stay. But every game you lose adds another game to our total games. Now, we don't know how many it is, so it's just n. We're going to write it as an expression, but we're adding whatever n is to the total. So the bottom here is going to be 17 plus n. And that's the expression. Since they're losing those games, if they were winning those games, we would have to add it to both the numerator and the denominator. And now, how many games would the team lose and still have a winning percentage above 600? So first of all, let's see where we're at right now. 11 out of 17. I'm above 600. I'm at 647. So if I lost my next game, 11 divided by 18, so I still have 11 wins, but I've played 18 games. Drop all the way to 611. That's a pretty big drop, right? That's 36 points pretty much. So if I drop another 36 points, I'm probably below 600. So let's take a look. If I still only have 11 wins, but I've played 19 games, my winning percentage is now 578. Rounded up, 579. So to answer the question, how many games can they lose and still have a winning percentage? This is where they're at now. They can lose 1 and be above it. As soon as they lose 2, they're below it. So to answer the question, how many could they lose and still have a winning percentage above 600? It's just 1 game. Okay, next up is number 7. It says the ratio of adults to children is expected to be 2 to 5. So for every 2 adults, there's 5 children. So this is like your parts. Okay, so if there were 7 people there, you would expect 2 of them to be adults and 5 to be children. I went back and double checked to make sure I had it in the right order. It says the ratio of adults to children, and then it says 2 to 5. So that's how you tell which one's which. They told you the order right here. The first one is adults compared to children, the second one. So 2 to 5. This is your adults, and this is your children. So not your total, not 2 out of 5, it's 2 to 5. So out of 7, 2 adults, 5 children. So we're going to compare this to 200 people. If 200 people attended, how many are expected to be children if it's following this same ratio? So 2 parts are adult, 5 parts are children. It's 200 total. So we're going to basically take the 200 people and split it up into 7 parts. 2 of those parts are adult, 5 of those parts are children. So we're going to divide by 7. Now, 200 does not divide perfectly by 7. So I get this. I'm going to go ahead and just write all that down, but I'm going to leave it in my calculator. This isn't the answer. This is one part. The question's asking you how many are expected to be children. So that's the 5 parts. So 1 part is this number. So I have to times it by 5 to figure out the children. So again, that's why I'm just going to leave it in my calculator and hit times 5. So I don't have to retype that whole number in. And so here's my answer. Again, not a perfect number, but we are talking about people. So about how many people would you expect to be children? I'm going to round this up. That 8 kind of rounds it up. But I'm going to say about 143. All right, the next number we did was number 9. So for part A, in 4 minutes, Leanna can type 140 words. If she has an essay that's 700 words long, about how long will it take her to type it? So there's a couple different ways you could do this. You could simplify this down to a unit rate and find out how much for 1 minute, how many words in 1 minute. That won't specifically help you here. You could use it, but you could also find out how many minutes per word. And once you know how many minutes per word for 1 word, it's going to be a piece of a minute, obviously, a small piece. Once you know how many minutes for 1 word, you could times that by 700. So that's one strategy. But for this specific question, I went ahead and I checked, well, does this go in nicely? Does 140 words go in nicely to 700? And it does. So 700 divided by 140 is exactly 5. So if you took 140 words in 4 minutes 5 times, you're going to end up with 700 words. So because of that, because 700 divided by 140 is 5, I can just take the 5 and times it by the 4 minutes, and I know it's going to take 20 minutes total. Now the other way to do it is to get it down to a unit rate. So I want to know how many minutes per word. So it's 4 minutes for 140 words. So if I divide that, that's how many minutes per word, how many minutes for 1 word, and then I would take that and I would times it by 700, because this is how long it takes for 1 word, and if I'm going to type 700 words, that'll give me that. So obviously 4 divided by 140 is going to be a real small number, and it's not even a perfect number, so I wouldn't even write all that down, but I wouldn't round it. You just leave it there. So this is how much of a minute it takes to type 1 word. So a very small piece. If you're looking at a percent, it's 2%. Okay, 2% of a minute to type 1 word. And so I'm just going to go ahead and times this by 700, because this is how long it takes for 1 word. So if I'm going to type 700 words, boom, there's my answer of 20. But I think for that one, our first strategy is a lot easier. Now, part B. This one, I think creating a rate is a good strategy. So it says in 5 minutes, he can type 160 words. How many words can he type in 12 minutes? So this is one where if we can get this down to how many words per minute, every minute, 1 minute, 2 minute, 3 minute, this many words, we can quickly figure out, well, how many will he pop out in 12 minutes? So I need to know how many words per minute. So that's how I know to set it up like that, words per minute. How many words in 1 minute? And then I can quickly, easily find out how many words in 12 minutes. So he can do 160 words in 5 minutes. So if I go ahead and divide that, 160 divided by 5, it's 32. So that's words per minute. So 32 words every single minute. I'm going to go ahead and just times that now by 12 to find out how many he can do in 12 minutes. So 32 times 12 is 384. Okay, next up is number 10. So they got a little picture here going back to some geometry. So it says recall that 2 angles are supplementary if the sum, when you add them together, it equals 180. And this is what it looked like. You learned this in middle school. A straight line, when it's split up into 2 angles, is 180 degrees because a full circle is 360. So this cuts a circle in half. So everything up here is 180, split into 2 pieces. So those 2 angles are called supplementary angles because they add up to 180. So it tells you have angle ABC, so that's this space, and CBD, that's this space. They're supplementary. And the ratio of their angles is 7 to 3. So find the measure of each angle. So if this was 10 total, this would be 7 and this would be 3. 7 parts to 3 parts. but it's not 10 total, it's 180 total. But it's 7 parts plus 3 parts for a total of 180. So we're splitting this into 10 parts. And so if I go ahead and divide 180 by 10, that's just 18. So each part is 18. And so one of them's 7 and one of them's 3. So 7p and 3p. We're just going to go ahead and we're going to multiply. 7 times 18 is 126. And 3 times 18 is 54. And you can always double check your work. We just talked about how they're supplementary, right? They need to add up to 180. So if you made a mistake in your work, they're not going to add up to 180. But go ahead and add those together. We get 180. We know we've got the right answer. Okay, moving on to number 12. Now we're in the review section. So for what values are they undefined? So if it's undefined, the denominator is 0. You cannot divide by 0. That's why it's undefined. So 2c plus 9 has to equal 0 to make this undefined. You're just going to solve this out. So minus 9. Get negative 9, divide by 2. And so c equals negative 4.5. If you plug that in, 2 times negative 4.5, it's negative 9, and then negative 9 plus 9 is 0, which would make this undefined. 13, tell whether each fraction equals 99 over 100. That means it would simplify down to 99 over 100. They're going to be equal to each other. They also will give you the same decimal if you divide. So 99 divided by 100 can be 0.99. What if we had 999 divided by 1,000? At first glance, it kind of looks like they would be equal to each other, but they're not. It's a different number. You also could put the fraction in, 999 over 1,000. Let the calculator try and simplify it. It's just going to give you the same number back because it is simplified. So it is not going to simplify all the way down to 99 over 100. So for part A, we will say no, it is not equivalent. Part B, you've got the 99 over 100. It's just worrying about these negatives. We have the negative in front. We also have a negative on the top and the bottom. So we know a negative divided by a negative is a positive. So these two cancel each other out. But when they're gone, we still have this. So in total, this entire term here is going to be negative. And so it's not going to be equivalent to the positive version. Letter C, you could get real involved here and try and figure out what this number is. But just put some reason to it. When I look at 99 over 100, the 99 is smaller than the 100. If I take 1, which happens to be the same number as I see up top here, and I take something away from it, it's going to get smaller. So regardless of what this is, if you don't have to go through all of the computation to figure out the number down here, 1 minus something, it's going to give me a number smaller than 1. So up here, my numerator is smaller than my denominator, but this would create a denominator smaller than my numerator. So clearly, that's not going to be equivalent. And letter D, we know that if we take division and turn it to multiplication, the second number is the reciprocal. So it's going to look like this. And when I go ahead and multiply across here, I'm going to get a really big number on top, and I'm going to get 49 on the bottom. When you multiply by 100, you just add 2 zeros. So it's going to look like this. And again, it's 99 over 100 we're trying to compare this to. So the top should be smaller than the bottom, or it's clearly not. So the answer here is also no, not equivalent. All right, here they want you to look at the difference between the operations. They're giving you the same two terms, x over 4 and x over 5, and asking you to do the 4 operations. So starting with addition, you can't add until you have common denominators. So we need to change these to 20s. So to get this one to a 20, I had to multiply by 5, so the top is 5x. To get this one to 20, I had to times by 4, so this is 4x. And so now I can add them together, and so it's 9x over 20. Part B, now we're subtracting. Well, just like addition, we have to change these. Oops, let's subtract. To common denominators, they're going to be the same, right, when we convert them. So instead of adding, now we're subtracting. So 5x minus 4x is just a 1x over 20. Multiplication, now we don't need common denominators. We just go straight across. X times x is x squared. 5 times 4 is 20. And then letter D, dividing. Well, like we've really stressed a lot lately, we don't divide fractions. We flip it and multiply by the reciprocals. So this becomes 5 over x. Now you could cancel now if you wanted to, if you see it. So we're going to cancel our x's. Our final answer is going to be 5 over 4. If you didn't see that, you multiply across, you end up with 5x over 4x. And now you can go ahead and cancel those out. And either way, our final answer now is 5 over 4. Okay, 15. The volume of a box is to be less than 20. Less than 20. The key to this question, though, is it says 20 meters, and then they give you something that's in centimeters. Now, there's 100 centimeters in a meter, so we need that information. So the dimensions are 185 by 250 by something, so we have to figure out what the height is. Volume is length times width times height, so we need that to come out to less than 20 meters. So first of all, this isn't a meter, so we need to turn it into a meter. So 100 centimeters would be 1 meter. So this is not quite 2 meters. It's 1.85. Because it's 100 for 1, you're dividing this by 100. And so this is actually 1.85 meters. This is 2.5 meters. We don't know what the height is, but we do know that this has to come out less than 20. So if we multiply 1.85 times 2.5, we're going to get 4.625. That times h, the height, has to be less than 20 is what we're looking for. So we're going to go ahead and divide by 4.625. Okay, which gives me this. So not a perfect number, but we're going to go ahead and move this back. So again, this is in meters, so we need centimeters. So we're going to go ahead and slide this over 2 spots. And so it's going to be 432. And so we've got h needs to be less than 432. And of course, you'll see this in the book. It has to be greater than 0 because obviously your height is not going to be negative. But if you just said less than 432, it does make sense. Mathematically, it's incorrect. You do need to say that it's more than 0, but we can accept that a height is going to be positive. All right, and then the last one, 16. What fraction of a complete turn is 75 degrees? So a complete turn is 360, so 75 out of 360. They're asking what fraction. If they asked for a percent, you would divide these and get the percent. But they said what fraction. Now you always need to simplify. So let's go ahead and let the calculator do the work for us. Pull up your fraction. 75 out of 360 is 5 out of 24.